day everyone. In this video, we unravel the mysteries of database performance. Today, we are embarking on an exciting journey to conquer a common nemesis in the SQL realm. Picture this. You are diligently working on your database, but every time you perform an insert, it feels like you are hitting a roadblock. That's right, the infamous last page insert contention. But fear not, my friends, for we are about to tackle this challenge head on. You might have heard whispers of a potent solution, a transformation that involves converting the clustered index on your primary key into a non-clustered index. And here is the kicker. If your primary key column happens to be an identity column, you are in for a game-changing strategy. Get ready to journey with me as we unravel the intricacies of this technique, step by step, and also we will be performing this head on. By the time we are done, you will not only grasp the concept of last page insert contention, but also possess a powerful tool to unleash faster, smoother inserts. Whether you are a seasoned database wizard or a SQL Server newbie, this video promises insights that will elevate your database game. So buckle up because we are about to unravel the secrets to reducing last page insert contention once and for all. Let's get started. In our earlier video titled SQL Server Performance Series, SQL Server 2016, Unveiling the Last Page Insert Contention, we delved into the issue of deteriorating insert performance. The tests that we performed revealed sluggish results with a total of 1230, that is 1230 executions of the insert stored procedure within 5 minutes execution, each taking an average of 24 seconds to complete. Now, in this video, let's explore a potential solution or a workaround and gauge the extent of enhancement it brings to the table. Let's head on to the SQL Server Management Studio. What we'll do is we will look at our table 1 structure where we had insert performance issue last time. So if I look at it here, we have 3 columns. Column 1 integer, it's an identity column. So if we see here, column 1 is an identity column. Column 2 is nvarchar 100 and column 3 is again integer. Okay. So what I understand is as a recap, when we did the test last time, we were able to see within 5 minutes, we were able to execute this insert stored procedure close to 1230 times. And the average time it took for each stored procedure execution is 24 seconds. Now what we are going to do is we will introduce the solution 1, which is to create a non-cluster index on the primary key. Okay, and then we will see if there is any improvement here. Okay, and if you look at it here, I've already started the SQL log scout just to capture the data. Now what I'm going to do is I'm going to look at the primary key constraint, and then what I'm going to do, I'm going to drop the primary key constraint and then add the primary key constraint pk underscore column 1, but this time I'm not going to create a cluster index. That is as soon as you create a primary key constraint, a cluster index will be created automatically. But now what I'm telling is column 1 would be the primary key, but we will need a non-cluster index. That's what I'm going to tell, and this is done here. So now this is one option where you can create a non-cluster index on the primary key, or what we can do is we can create the table and then we can provide the information directly. That is column 1 integer identity 1 comma 1 primary key non-cluster. So these are 2 ways. First one is to drop the constraint and then add it as primary key non-cluster, or while creating the table we can instruct SQL Server to create a non-cluster index on the primary key. So I will execute this one as well. So now what I'm going to do, I'm going to start the insert stored procedure. It is going to run for 5 minutes. So let's start it. So now let's wait for a couple of maybe let's wait for 30 seconds or so for it to start. In the meantime, let's click on a new query window and then use sp underscore who is active and then see what is happening. So if we see here, right now I'm seeing page latch underscore sh. That's what I'm seeing right now. And the wait time is close to 300 milliseconds. Let's go to that tool here. So now if I see here, what I'm seeing is like seeing the average DB time is close to 25 seconds. That is what I'm seeing. So let's wait for this to complete. It's gonna take like close to let's say 5 minutes. 300 seconds is going to be 5 minutes. So what I'll do is like I will pause the video right now, and then once the test completes for 5 minutes, I will resume it back. Okay, so the tests are completed. We ran this test like we had 4 workloads, and we were executing this stored procedure USP underscore insert data, which basically inserts data into that table 1. We ran it for like close to 300 seconds. And what we're able to see is like the stored procedure execution is close to 1,437 execution. So previously, when we had cluster index on the primary key column, which is an identity column, we were able to just insert like execute close to 1,230 stored procedures only, with an average execution time of 24 seconds. But now, after converting the identity column, which has the primary key, from cluster index to non-cluster index, what we are able to see is like we have a slight improvement wherein we are able to execute close to 1,437 stored procedures. That's the execution. It is like up by close to 200 executions, and also the average DB time came down from 24 seconds to 19 seconds, close to 20 seconds. So we were able to save like 4 seconds on each execution. There is an improvement for sure, but we can't attribute it as the perfect solution here, because what I'm able to see is like previously it is executed close to 1,230 executions for each workload, but now it is increased from 1,230 to 1,437. If we sum up all the 4, it's going to be like an improvement of 1,000 execution, and also like the average DB time is also decreased. Like it came down from 24 seconds to 20 seconds. So we were able to save 4 seconds on each execution. This seems to be an improvement, like kind of a good improvement, but doesn't seem like a solution. So now what we'll do is like, let's head on to the Nexus reports from the Nexus Power BI report, and then look at what is the wait time and things like that. And then let's see if we are seeing page latch or something else. And now if I look at the CPU utilization, as soon as we started the workload, we're able to see like an average SQL CPU utilization is close to 52% till the workload like ran for like 5 minutes. Yeah, and let's head on to waits and latches, and then if I look at it here, what I'm able to see is like 65%, that is close to 60%, is 66% is on page latch, down from 73%. So last time when we did the test on the table with identity column as primary key and cluster index, we were able to see like page latch was close to 73%, and now it is 66%, so down by 7%. Okay, so there is definitely some improvement as far as page latch wait type is concerned, but we have not completely ruled out page latch contention. Yep, but this seems to be a good improvement. Okay, so now what I'm going to do is like let's look at the read phrase report, and then what I'm able to see is like this particular stored procedure, which we know like was the only stored procedure that was running on the database server, and it is USP underscore insert data, which basically inserts data into that table one. And if we are able to see, that seems to be occupying the top slot as far as CPU reads, writes, and duration is concerned. And if you look at it, yeah, the total CPU is 493,000, and then duration is insanely high. So that means like we clearly can see that we were basically waiting on something. Yep. So the total CPU is like in 6 digits, but in total duration is like close to 12 digits. Yep. So what we are able to understand is like the whole the execution of these stored procedures were waiting on something, and we know that it was basically waiting on page latch. So let's look at it further. Yeah, let's go back to the SQL Nexus here, and then let's look at waits here. So if I see here, we basically have to look at the wait statistics and also the blocking here, and then let's see like where we are waiting. So this also clearly tells like if we see that SQL Nexus clearly points out that we were most of the time waiting on page latch wait. Yeah, so that is same as what we found in the Nexus report, Power BI report as well. So 66% we were basically waiting on page latch wait. Let's head on to SSMS, and then what I'll do is like I will first run this query, which basically lists out the top queries, top resource consuming queries. And so USP underscore insert data seems to be utilizing much of the resources, yeah. And if you see, yeah, CPU underscore milliseconds and compare it with duration underscore ms, which reiterates that these queries are waiting on something, because there is a huge difference between the amount of time spent by these queries on the CPU, that is, it is actually running, and duration seems to be like very, very high, which basically tells like even though these queries were utilizing this much of CPU, rest of the time was basically these queries were basically waiting on something, and we know that it is basically waiting on page latch. So what we'll do now is like, since we know like it is waited on page latch, let's run this query and then see if it coincides with what we have told. And if we see here, what we are able to see is like this USP underscore insert data, this many like if the duration, if you see here, this much milliseconds of page latch ex and this much milliseconds of page latch sh, and we have write log latch sh and latch ex. But when we compare these weights, it is pretty clear that this query is basically waiting on page latch underscore ex and page latch underscore sh. This is somewhat similar to what we experienced in the previous video, but the only difference is like after we change the primary key from cluster index to non-cluster index, this page latch has basically come down. If we look at it in the previous video, we were able to see like page latch weights were close to 73-74%, but now that has come down to 66% when we looked at the Power BI report. That's it for this video. Thanks for watching. Have a great day. Jai Hind.